In a previous video, I hinted at using multiple resistors and how that splits the voltage, how voltage can be divided over multiple resistors. And that might not seem that useful to you, but I assure you it is, because it's what makes a lot of electrical equipment tick, including light dimmers and volume faders and equalizers on a mixer, and also so I've mentioned that resistors split voltages, but how do they do that? Well, if we take a look at the slide metaphor again, well, we can divide the height of two slides in different ways, and we can do them like this. Get the light shining on it there, so we can have it divided equally or not so equally, and we can do everything in between, obviously. And we can do that with resistors as well, with electricity. So we're going to have to kind of ignore the slide idea for a little while and just go with electricity, okay? Now with electricity, instead of slides, the voltage actually prefers the highest resistor, because it's going to push the hardest on the most resistance, because it needs more pushage, which I know is not a real word. More pushage, more pushing power. So the voltage will prefer a higher resistance. So if there is a twice as big resistor in the circuit, it will get twice as much voltage. If it's 3 times as much, it gets 3 times the voltage. It's really easy. And looking at my script here, and I'm going off script again, as I usually do. That's actually pretty much what I wanted to say. If one of the resistors was, say, 3 ohm, and the other one was 1 ohm, and there was a total of 10 volts, well, the 3 ohm resistor would get a 7.5 volts, and the other one would get 2.5 volts. The total still is 10 volts, but one of them gets 3 times as much as the other. So I want you to think about this circuit. I'll get an overhead shot of it. And I want you to figure out the voltages on each resistance. Now, I want you to also pause the video for that and actually think about it and do it, because I know that most people can actually figure out how to do this. It's not that difficult if you kind of just put your brain to it. And I know it requires a little bit of willpower to pause the video and just go do this thing. But if you do it, you can call yourself a winner. And if you don't, well, you can call yourself a little bit of a wuss. So I'm going to give you a timer here. Go do it. Pause the video. And then make the thing. So, how does one go about this? And I hope you got a good answer, but I'll show you. If we have this question here, well, we need to figure out how much of the percentages, if you will, go towards the 150 and to the 1.2 kilo ohm. Now we have 230 volts in total, but let's just ignore that for a little bit. We just want to know how big the part of 150 is and 1.2 kilo ohm. So basically we're working with percentages or fractions. So we kind of got to figure out how much is 150 of the total ohm we have. We're in a series, so we can just put them together. So if we say 150 plus this, because that's 1.2 kilo ohm, well, then we'll have the total, right? The total resistance of the circuit there, the equivalent resistance, if you will. Now, if I take 150 and divide by that total, well, then I will know how much 150 is of the total. So I'll have a fraction of that. And that is, let me get my calculator, 0.1 repeating, which also means 11.111%. So this one, 150, is
a fraction, 0.11111, repeating. And the other one will have to be 0.99999. But we can calculate that by doing pretty much the same thing, but saying this. And let's just calculate that real quick. We got this divided by opening the bracket. Ooh, we don't want that. 150 plus 1200 is, I was wrong, I did some dumb math in my brain. It is 0.888. Alright, so this just repeats, and I made the stripe too big, but this just repeats forever. It's a fraction, and they often do that. What can we do with that? Well, we know now that this is kind of like a percentage. This is like 88%, this is like 11%. So 88% of 230 volts, not 10 volts or 100 volts, right? So if we do this times 230, and the same goes for this one, times 230, well, what do you get? Let's see, 204.49 volts. Then we have an amount left, so we can also just say 230 minus our previous answer, which I don't know how to do here. Minus that is, here we go, 25.5 volts. So we have our U1 is 25.5 volts, and our U2 is 204 4/9. All right, so that's how you do splitting of the voltages. Now, what did we actually do? There's a actual function for this, or an equation, if you want to call it that. Let's just get that out of the way. Get a new piece of cardboard here. What we just did is x, so 1 or 2 or 3 or 4 or 5, it doesn't really matter, is U total, which usually is just written with just a U without the total, but to make it more clear, times UX over UX plus UY. You'll also find these X and Y's as just 1s or 2s. And this is how you do voltage splitting. So if you want to find out how much voltage resistor X gets, then you have to get your total voltage, multiply it by that part that you calculated. So this is the actual equation that, if you think about it for a little bit, you probably got this working. I hope you got this working. That's the equation. That's how it works.
All right, now let's take a look at this little circuit here, which is a voltage splitter. And I wrote here, anything here between these two little dots behind our resistor 1 is in parallel with resistor 1. So what that means is that anything that comes off of these little prongs here from resistor 1 is going to be the same voltage. It's going to get the same voltage as resistor 1, because in parallel voltage stays the same. So the total voltage for this part of the circuit behind R1 will be the same as the voltage R1 gets. So you can divide the voltage over R1 and R2 and just get a part of the voltage for the rest of the circuit. Now this is very useful, because if you kind of select the resistors in a specific way, you can also select the voltage on this part of the circuit. Now if you get a variable resistor, or like a potentiometer or a fader, that's just a resistor that goes up in resistance or down in resistance, you can change the resistance here. So let's make that a variable resistor. There we go. And now we can change this resistance. And so the division of the voltage, the splitting of the voltage, will either prefer this one or this one. So the voltage will go up or down. We can also make this one a variable resistor, of course. So if this gets a really high resistance, well, all the voltage will go on this thing. So none of the voltage will go on this thing. And if we're thinking about audio signals, well, a high voltage means a loud signal. So with this, we can actually make a volume fader on a mixer or a light dimmer that works on voltage, because we can just kind of turn this knob here, and that will actually change the voltage splitting in this little circuit. So this part of the circuit that's in parallel with R1 won't get as much voltage because all the voltage is going over R2. And you see this a lot. It's a very prevalent thing in circuitry, just, you know, mixers, all sorts of things. It's really, really useful. Next time we're going to look at, well, AC/DC, not the band. It's going to be fun. Maybe. I hope it's going to be fun. Oh, yeah, and always, as always.
While I am a licensed physics teacher, this does not make me an expert on the subject. I'm wrong sometimes. Sometimes I know I am, but simplify my explanation at the expense of being completely correct. Sometimes I actually don't know. In either case, I've got a pretty good grasp on the laws of nature and how things work. For the purposes of these videos, the exact correct descriptions of phenomena is not important. I'm trying to give students a new way to look at this world with a technical and logical view. Please feel free to contact me to discuss any of the subject matter within the video. Have a good one.